So in this warm-up, like I said earlier, we're looking for an exponent that makes this true. I'm going to go ahead and rewrite all of these statements from logarithmic to exponential form, so it makes it easier for you guys to see what we're looking for. All right, so for example, log base 2 of 64 means 2 to the power of what gives you 64. In this case, that needs to be a what? A 6. 2 to the 6th power gives you 64. All right, 1/8, log base 1/8 of 64. So that is 1/8 as your base to the power of what gives you 64. This one's tricky. The way I want you guys to think about it, if you weren't able to solve this, is we typically use a negative exponent to turn a whole number into a fraction. It's the same thing backwards. To turn a fraction into a whole number, you must use a negative exponent. So what should we use in this case? Negative what? Negative 2, right? 8 squared gives you 64. So the solution for this one is negative 2. Okay, 27, log base 27 of 9. This one might have been challenging, considering that we didn't spend a lot of time looking at fractional exponents. For this one, the way you want to think about it is, how do you even think about this one? Let me see if I can explain it to you. The way that we learned it, right? Because we learned it with like the grouping. So let's see, 27. I guess we could do the following. We could say, okay, 27 gets split up into 3 numbers, and we know 2 of them are going to multiply to 9. So really, we're looking for another one. So in this case, we have 2 groups of 3 that multiply to 20. Or sorry, 3 groups of the same size, but we only want 2 of them, right? 3 times 3 gives you 9. So in this case, our solution would be 2/3. Now this, like I said, this is challenging, so we won't be testing you on this. Don't stress, all right? Don't stress. Let's look at the next one, log base 10 of 10,000. So this is 10 to the power of what gives you 10,000. An easy way to think about this one is count the number of zeros in your solution, and that should match the exponent. So how many zeros do we have in 10,000? We have 4 of them, so your solution is 4. Lastly, log base 10 of 1. So 10 to the what power gives you 1. Anything to what power gives you 1? 0. And finally, log base 10 of 10 over 5, or 10 to the 5th. So 10 to the power of what would give you 10 to the 5th? What do I need to turn that question mark into to get a true statement? The same thing on both sides. I would need to turn that into a 5. 10 to the 5th equals 10 to the 5th. So in this case, we have 5 as our exponent. Okay. All right. Do you have any questions so far? So everything except for C, for problem C, is stuff that you should feel comfortable with and you should be able to do with minimal help. Okay. All right. Let's look at some guided notes now. So everything we have done with exponentials and logs can be done with E and natural logs. All right. For example, let's say we want to evaluate log base 10 of 100. Log base 10 of 100 we can rewrite as 10 to the power of what gives you 100? In our case, what would that be? Count the number of zeros in your solution. How many zeros do we have in our solution? 2. So in this case, that question mark, the exponent, is a 2. Okay. Let's look at the second example. Actually, hold on. There's a U try. Go ahead and try the one at the bottom. Log base 10 of 10,000. So try the one right underneath example 1. Take about 15 seconds. All right. Let's take about 5 more seconds to finish up. Okay, what do we get for log base 10 of 10,000? So 10 to the power of what gives you 10,000? That would be 4. All right, we all agree with this one? Okay, should be pretty easy. All right, example number 2, evaluate natural log of e to the 4th. Now, We only use natural log when there is base e, because natural log goes with natural base. E is known as the natural base. So anytime that you see e, you're not using log, L-O-G, you're using ln for natural logarithm. However, for now, I'm going to rewrite this just so you guys can visualize it, and this might make more sense for you. Ln of e to the fourth is the same as having log base e of e to the fourth, right? So in other words, because natural log has base e, we have the following problem. E to the power of what gives you e to the fourth? What must the exponent be to make this a true statement? 4, right? If I have e to the fourth, then that would equal e to the fourth. That would essentially be the same thing on both sides. Okay, so I don't want you guys to get in the habit of rewriting it like this. I only did it for this example so that you are able to visualize that ln is actually base e. Okay, but when you try it, don't write it like this. It's going to get confusing for you. So try the next one. Ln of e times e times e. I would recommend condensing those e's. If you have e times e times e, then you have e to the power of, you're going to rewrite that. Take about 10 seconds. All right, so how can I condense ln of e times e times e? I could rewrite this as ln of e to the power of what? 3. Which then is asking me, well, e to the power of what gives you e to the 3? Then that would be a solution of 3. Okay, awesome. All right, evaluate log base 10 of 0.1. So 10 to the power of what gives you 0.1? You can do this two ways. You could turn 0.1 into a fraction. Because the 1 is in the 10th place, I could rewrite this as 10 to the power of what gives you 1 over 10. And this might be helpful for a lot of you guys. Or you could also count how many values are after the decimal. In this case, because there's only one value, then that could also be your exponent as a negative. In this case, the question mark would equal -1. All right, because 10 to the first gives you 10, but 10 to the negative first is going to turn that into a fraction, 1 over 10. And so that's how we get that. If you're using the second example, or the second method. Using the first method, like I said, you're just counting the number of the numbers after the decimal and just turning that into a negative. Let's see if that made sense to some of you guys. Try out the next one. Log base 10 of 0.0001. Oh no, there's 2 zeros. 001. Let's take about 10 more seconds. Okay. So in our case, we have the following. We have 10 to the power of what gives you 0.001. If you're using the first way I showed you, where you're counting the numbers after the decimals, then that would be 1, 2, 3. And so we could say that the question mark is equal to -3. All right, that's doing it that way. If you're doing it the second way I showed you, then it would look like this. 10 to the power of blank is equal to, the 1 is in the, so the first number is the tenths, hundredths, and then thousands. So it would be 1 over 1,000. So then question mark would still equal -3. So regardless of which approach you choose, your solution should be -3. Now, whichever one you want to do, I'll leave that up to you. Whichever one makes more sense, but those are the two approaches that you could do. Okay. All right. I believe we have 3 problems left to do, and then we should get started with the red light, green light. So let's look at this first example. Suppose we want to solve the following. 5e to the 2x minus 3 equals 97. Remember that to solve for x, we must solve algebraically using SATMAP. So we're going to go back to using SATMAP. SATMAP is PEMDAS backwards. So subtraction, addition, division, multiplication, exponents, and finally parentheses. So we start with S for subtraction addition, or SA for subtraction addition. We have -3. What is the opposite of -3? +3. So begin by adding +3 on both sides. 5 times e to the 2x equals 100. Cross out the operations that you've done or that you basically can't do. So if we just added, that means obviously we can't subtract. So cross those 2 out. According to our list, the next step would be D for division. So we're going to divide both sides by what? 5. Cross division and multiplication out together. So we're going to be left with e to the 2x equals 5 goes into 100 how many times? 20. All right. Now here we are doing exponents, right? Exponents. Now if I'm currently in exponential form, what must I do to get x by itself? I need to switch from exponential to what form? Logarithmic form, but in this case we have natural base, so not just any logarithm, but the what logarithm? The natural logarithm. So essentially what you're going to do is you're going to take the natural logarithm of both sides. And you can do it like this. You can write ln on both sides. Ln on both sides like that. And now when you take ln of e, because we have base e already assumed to be ln, then it's just going to bring the exponent down. So this is what's going to happen with this first line of the argument, the left side. ln of e to the 2x will just become 2x, right? ln will cancel the e out, so you'll just be left with the exponent, 2x. So you have 2x equals ln of 20. And now we can finalize this process by doing one final step to get x by itself, which will be to do what? Divide by 2. Now, this is where we have 2 solutions. And not 2 solutions in the sense that 2 different answers, but you have the following. You have x equals ln of 20 over 2, which is your exact answer. Exact answer, because this is what you would plug in the calculator. In just a second, I'll have you guys plug this in the calculator to get your approximate answer. I notice you guys don't have calculators, so come up and get some, please. For your groups. Okay, so once again, ln 20 over 2, that is your exact answer. So I just labeled it for you guys right there. If you want to label it as well, feel free to do so. What I want you to do next is I want you to find the approximate answer. So you're going to take your calculator, turn it on, and you're going to type in ln, look for the ln key next to the 4, ln of 20, and then divide that by 2. And so if you did this correctly, we should get the following answer. 1.498 if I'm rounding to the nearest 1,000. If you got anything different than 1.497 or 1.498, then double check that you did this correctly. If you did not close your parentheses, if you did ln 20 and divided the 2 without closing the parentheses, then really you solved for ln of 10, and that's different. That's maybe how you got a different answer. You must close ln 20, close the parentheses, and then divide by 2. Okay? All right. Are there any questions before we move on? Okay, then let's look at the next one. Same idea. We're going to go ahead and solve this using SADMAP, going backwards. So, raising your hand, what is the first step that you think I should take here? What must I do first? Go ahead. Add 2 on both sides. We get ln of 4x plus 11 equals 3. And cross out S and A. Can we divide or multiply? Is there anything in the ln side that we can divide or multiply? Are there any coefficients? No. So we can cross out D and M. All right. Now, this is where things have to change. So, we are currently in logarithmic form. We're going to convert this to what kind of form? Exponential. Now, natural log is base what? Not base 10, that would be a common log. Natural log is base e. So when I rewrite this in exponential form, I'm going to get the following. E to the power of 3 equals 4x plus 11. Right? So this is a log form, goes into exponential form. All right. Have we finished solving for x? No, we haven't. We repeat SADMAP again. What should I do next? In 4x plus 11, I should subtract 11. We get e to the third minus 11 equals 4x. Finally, what's the last move? Divide both sides by 4. So this is what we get. Same thing, 2 answers. You get an exact and an approximate. You get x equals e to the third minus 11 over 4. This is your exact answer. Go ahead and plug that in your calculator to get your approximate answer. To get e in your calculator, you must hit second and then ln. Second and then ln. That'll give you e. Do e to the third minus 11. Evaluate that first and then divide it by 4. And so if you are doing this correctly and if you are able to plug this in right, then you should get the following. 2.271. Please call me over if you did not get the solution that I have on the screen. So you have to do it separately, like this. Evaluate e to the third minus 11 first, and then divide that by 4 to make sure that your answer is going to work out. So I did it in 2 different steps. I did it. This would be 1 step, and this would be a second step. When you do it like this without parentheses, then it's going to evaluate 11 over 4 as a number, like a different number. Okay. Yeah. Anybody else? Yeah? Did I type it in right? No. So you have to do e to the third minus 11 first, and then divide that by 4. Yeah. Anybody else? Good. Okay. If you got something wrong, then probably what happened was you didn't use parentheses correctly. If you don't use parentheses, it'll evaluate 11 over 4 as a division. And then whatever you get from that, subtract from e to the third. Okay. Okay, I have one final problem for you guys, and then we'll do a red light, green light. So let's jump to the next one. Find the inverse of the following. This is a lot. 7e to the x minus 3 over 2 plus 5. If we're finding the inverse, then this is where we go back to writing the steps. So I'm going to call this f of x. All right. Remember that when you're making your list, the first thing you want to do is you want to look for the x. Where is the x and what is going on with the x? So I look for the x, I see x minus 3. So my first step should be box minus 3. All right, then I notice that x minus 3 is actually an exponent for e. So my second step is going to be e to the box. Then I notice that there's a 7 in front of the e. So that means we're multiplying 7 times the box. Then I look and I see that all of this is a numerator for 2. So step 4 is box over 2. And then all of this is going to be added with 5. So that's box plus 5. Okay, so about 5 steps here. All right, let's go ahead and make our inverse. F inverse of x, make our column. You're starting with the 5th step, doing the opposite. Opposite of plus 5 is minus 5. Opposite of dividing by 2 is what? Times 2. 2 times the box. Opposite of multiplying by 7 is divide by 7. Box over 7. Okay, this one should be easy. The opposite of e, the opposite of the natural base is the natural log, the ln. So ln of the box. And then opposite of minus 3 is plus 3. Okay. So with our list made, we can actually write out our equation. So f inverse of x is equal to, only in the first step do we replace the box with an x. In the rest of the steps, you take the subsequent step, meaning the step before it, and you plug it into that box. So I'm going to start with x minus 5. So that's x minus 5. Then we're saying we're going to multiply this by 2. Then we're going to divide this by 7. Then we're going to take the natural log of all of this. And we're going to add 3. Okay. All right. So overall, whoa, my bad. Overall, not too difficult. My foot got stuck there. You can see that, you just got to follow the steps. I think the hardest part is identifying the inverses. So anytime you see e, don't forget the opposite of e is the natural log, right? Natural base, natural log, same thing. You start with natural log, go to natural base. All right. Are there any questions on the notes, especially this problem right here? Okay. All right. Then in that case, let's take a look at the time. Okay. We're going to go ahead and get started.